For this next one, it says we're going to use this cost function c of x is equal to 5,000 plus 40x minus 0.05x squared. We're going to find the total and marginal cost at production of 100 and interpret the results. Keeping in mind again, marginal cost is to basically take the derivative of the cost function c prime of x. So total costs, what we'll find is to do that by plugging in the number for the original cost function c of 100. So that would look like 5,000 plus 40 times 100 minus 0.05 times 100 squared. That comes out to be a total of $8,500 for total costs for 100. Now for marginal, we need to find the derivative c prime of x. The derivative of the function above would be 40. And if we do the derivative for the next term, it would look like minus 0.1x as the marginal function. And to find the marginal cost for 100, we're going to plug in 100 to that derivative. 40 minus 0.1 times 100. That's going to equal to 30 for $30. Now what does that mean? It means that the costs are increasing by $30 per bike at 100 bicycles. Okay, and then the next thing says to find the exact cost of producing the 101st bicycle. To do that, let's find the total costs to make 101 bicycles. So going back to the original cost function, plugging in 101, that comes out to be a total of 8529.95. And if we take that number and subtract it from the costs for 100, so if we take 8529.95 and we subtract the 8,500 from above, the difference is a total of $29.95. So that's how much exactly it costs to make one more over 100. From 100 to 101, it'll cost $29.95 more. Approximately, though, the c prime derivative 100 told us $30. That's the approximation based off of the derivative, which is very close to the $29.95. Okay, and then the next part down below says to find the average cost and marginal average cost at a production level of 100 bicycles and interpret the results. So let's go about finding the average cost function. To find average cost function, we do c of x over x. So what that looks like is we put the entire 5,000 plus 40x minus 0.05 x squared all over x. Now, to take the derivative, I'm going to rewrite this as 5,000 over x plus 40x over x minus 0.05 x squared over x. And then I'm going to simplify it down a little bit. I'm going to simplify it to look like 5,000 x raised to the negative 1 plus 40, because I can cross out the x from top and bottom. I can also cross out an x from top and bottom on the other one, making it 0.05x. So we start out here for average cost function over x, and then I'm going to rewrite it like this. Because it wants me to find the marginal average cost function here. To do that, I need to find the derivative of the average cost function above. The derivative would look like negative 5,000 x to the negative 2. The derivative of 40 is gone, and it'll be net minus 0.05 for the derivative of 0.05x. So this is the marginal average cost. Let's write it as minus 5,000 over x squared minus 0.05. It also wants me to find the averages for 100. So at 100 units, average cost would be found by doing 5,000 plus 40 times 100 minus 0.05 times 100 squared all over 100, which is equal to $85. For the marginal average cost, we'll basically plug in 100 into that derivative we found up above. It'll look like negative 5,000 over 100 squared minus 0.05, which is equal to negative 0.55. So what this means is that average costs are $85 per unit, and these average costs are declining by basically 55 cents per unit when 100 are produced. Now, the last part says use the results from the last one to find or to estimate the average cost if 101 are made. Well, since costs are declining by approximately 0.55 or 55 cents, we can take the $85 and subtract away the 55 cents rate of change from it, leaving a $84.45 average cost when making 100.